Hello. Today we will continue our work on chapter 3, which is motion in two dimensions, and in particular on projectiles. And today I will introduce how we calculate the maximum height reached by a projectile, in addition to solving some problems. So reminder equations of motion during projectile. These are the equations of motion in two dimensions. Remember, in one dimension, there are only three, but in two dimensions, there are five, okay? And this last equation, just keep it in mind for a second. Just keep this last equation in mind for a second. V squared final y equal V squared initial y minus 20 delta y. Okay, maximum height. So where is the maximum height here? It is over there. And here is the maximum height reached by the ball. So if they ask me how to calculate this maximum height, here I have to remember that if I launch something, if I launch a projectile at the maximum height, V vector is along the x-axis. V vector is along the x-axis. If it's along the x-axis, it means it only has an x component. It means it only has an x component. So Vx only has an x component, and that's equal to V initial x. Okay? It does not have a y component, Vy equal to 0. Look at this vector. It's parallel to the x-axis. It means it's only along the x-axis. There is no y component, okay? So this is what we will be using, that Vy is 0. We use this in order to calculate the maximum height. So let's see how we do this. So assume they tell me I have a projectile launched at the initial equals something, with an angle theta equals something, and find the maximum height. So to find it, we use equation 5, the equation that I said, keep it in mind for a second, okay? So V squared final y equal V squared initial y minus 20 delta y. Vy is 0, Vy is 0, because it's at the maximum height, there is no y component, only x component, equal V initial y, which is V initial sine theta, minus 20 delta y, and that's how I get delta y. If it tells me find maximum height without specifying from where, it means with respect to the ground. So first I get delta y, and then I add it to the length, for example, here of the building, to find the maximum height with respect to the ground. Okay, so let's solve a problem, an exercise. A ball is thrown upward from the top. A ball is thrown upward from the top of a building at an angle 30 degrees to the horizontal with an initial speed of 20 meters per second. So here he's giving me the initial speed 20 meters per second and the angle. So what do I get immediately out of these? I get V initial X and V initial Y, okay? The point of release is 45 meters above the ground. So this is the length of the building. The height of the building is 45 meters above the ground. Part A, determine the horizontal and vertical components of the initial velocity. I do this very quickly. So this is part A. V initial X equal V initial cosine theta, and V initial Y is equal V initial sine theta. Okay, and here if you do the calculation, you get this is number 7, you get 17.32, and V initial Y is 10. Okay, So V initial is 20, theta is 30, V initial is 20, theta is 30. With calculations, I get these two values. This is part A. Find the maximum height reached by the ball with respect to the ground, okay? So here I have to do delta y. So what is delta? Delta y equal how much? When V final y equal to 0, because it's maximum height, so V of y equal to 0, and I need to calculate delta y. So I use the last equation. Okay, I use the last equation. V final y square equal V initial y square minus 20 delta y. This disappears. This disappears because V final y is 0 at the maximum height. Okay, and V initial y, we have just calculated it, it's 10. So we get 0 equal 10 square minus 20 delta y. You do the calculation and you get delta y equal 5 meter. Okay, so h, which is maximum height with respect to the ground, is 45 plus 5, which is 15. Okay, so this is part B. Part C, all these, by the way, are solved in the coming slides. I'm just doing them together. We're just doing them together, but it is solved in the coming slides. Part C. So let's erase, find some space to solve part C. Part C, let's do it over here. How long does it take the ball to reach the ground? So we want delta T from O to B. So what information do I have from O to B? I have delta Y equal to minus 45. Okay, do I have the initial Y? Yes, I have. I did it in the first part. It's 10 meters per second. Do I have V of Y? V of at Y? No. Do I have the acceleration Y? Yes, it is 10 minus 10, and it's already in the equations. So we want to calculate delta T. We come to this equation. Let's see which equation we can do. So the first one has to do with delta X. I cannot use it. The second one, delta Y, I have it. V initial Y, I have it. And I want delta T. So I want delta T. So I need to use this equation, okay, which is second equation. So delta Y minus 45 equal V initial Y 10 delta T minus 5 delta, sorry, minus 5 delta T squared. Okay, this is a quadratic equation. It looks like this: minus 5 delta T squared plus 10 delta T plus 45 equal to 0. Okay, so this is a quadratic equation. In order to use it, you use scientific calculator mode quadratic. So we go to a calculator mode equation. Mode. Each calculator is different, but you have to go to use scientific calculator to solve quadratic equation. According to a calculator, you have to Google how to use it, okay? Because each calculator is different than the other. So here you put that A is equal minus 5, B is equal 10. So A is whatever is next to the square thing. Then B is whatever is next to the no square thing. And then the number, you put it as C equal 45. And you get delta T equal 4.16 seconds. And you get two answers. Delta T equal minus 2.16. Of course, this is rejected because time cannot be negative, and this is accepted. So we get delta T equal 4.16 seconds. Okay, is there another way? Yes, I think in your math class, you're solving quadratic equations. You have to get delta, which is b squared minus 4ac, and then you do the calculation for delta t1 and delta t2. Okay. Part D, calculate the components of the velocity at impact. Let's do it here. B. I want to calculate here velocity at impact. So the velocity vector is like this at impact. Okay, I want to calculate VBX, VBY, VBX, VBY. X, VBY. VBX, we use this equation over here. It is V initial X, so it is equal to 17.32. We calculated it in the first part. And VBY is equal to, we come here, VBY is equation number 4. It's V initial Y minus 10 times delta T. So this is equal, V initial Y is 10 minus 10 times delta T 4.16, and we get the answer minus 31.6 meter per second. So these are the components of the velocity, VBX, VBX, and VBY. Okay, part E, this is part E. Part E, deduce the magnitude and the direction of the velocity vector. Here I have to remember that the magnitude is the square root of VBX square plus VBY square. This is the magnitude and square root or radical, okay, or radical. So you put a radical, and inside the radical these two answers, you will get the VB to be 36.03 or just 36 meters per second. And for the direction, we use tan theta equal VBY divided by VBX implies, or we just say immediately, we don't have theta equal tan inverse. Yeah, this means shift tan on your calculator. VBY over VBX. And you get theta equals, just plug the numbers, you get theta equal minus 61.27. Okay, this is part D and E. Finally, find the horizontal range of the ball. Let me okay. So find the horizontal range. I have to remember that the range is the distance from the point of sending the projectile until it reaches its maximum delta x. So the range is nothing but delta x. Range equal delta x from the beginning till the end. I come to the first equation. Delta x is what I want. V initial x, I have it, and delta t, I have it. So V initial x times delta t, which is implies delta x equal V initial x. We calculated it, it's 17.32 times delta t 4.16, and we get this answer to be 72.05 or just 72 meters. Okay. Now, if you go down with the slides, you will find that all the parts are solved. Okay, so the whole solution is here for the whole problem. Let's do another exercise. This is also in your booklet. So page 18, number 8. A projectile is launched with an initial speed of 60 meters per second at an angle of 30 degrees above the horizontal. The projectile lands on a hillside 4 seconds later. Okay, so this is an important piece of information. What is this? This is delta T, okay? Force delta T delta T is equal 4 seconds, okay? And they're giving me the initial and theta. From these, I can calculate V initial X and V initial Y. Okay, part A. Part A. What is the projectile's velocity at the highest point of the trajectory? At the highest point. Here I have to remember that at the highest point, V initial X is equal, Vx is equal to V initial X, which is 52 meters per second, and Vy is equal to 0. Okay, so they're asking implies V at the highest point, V maximum is equal to 52 meters per second. It will be the square root of 52 square plus 0 square, and that will be 52. That will be 52. Okay, part B. Find the maximum height reached by the projectile. Find the maximum height. Find the maximum height. Just a second. I'm sorry. Okay, so I just added the equations here. So what is the projectile's velocity at the highest point of the trajectory we found it? Find the maximum height reached by the projectile. So in order to get the maximum height, we use the last equation, okay? We use the last equation, V Fy square equal to V initial Y square minus 20 delta Y. V Fy square is 0. 0 equal V initial y 30 square minus 20 delta y. We get delta y equal 45 meter. Okay. This is the maximum height with respect to the ground. The projectile is launched from the ground. Okay, so we have just calculated this distance. Okay. So here you just have to remember that at the maximum height, the velocity vector is along the x-axis. This is why the x is equal to the initial x. Part C, what are the horizontal and vertical displacement of the projectile? I have delta t. I have delta t. Okay. So delta x, I have to use the first and second equation. Delta x equal v initial x times delta t. I have both v initial x and delta t. I have v initial x and delta t. And for delta y, sorry. Delta y equal v initial y delta t initial y delta t minus 5 delta t squared. Okay, I have the initial y, I have delta t, I have delta t, I get delta x and delta y. The answers are delta t x, delta x equal 208 meter and delta y equal 40 meter. Okay, last part, let's erase a bit. Part D, using part C, find the straight line distance from where the projectile is launched to where it hits the target. So I want this distance from here to here. Distance between 2 points, so this is math. Distance between 2 points is equal to radical of x final square minus x initial square, okay, plus y final square minus y initial square. So radical of this plus and close the radical. So this is how we get the distance. Okay, which is nothing but, so the distance is equal to radical. What is x final square? Sorry, x final minus x initial square plus y final minus y initial square. So what is x final minus x initial? It is delta x, right? And what is y final minus y initial? It is delta y. And I have these two numbers. I calculated them in part C. I just plug them here and you will get the distance equal 211.8. Okay, so this is our lecture for today. All the detailed solution you will find here. Okay. If you have any questions, just send me an email and we go through it during the live session. As for now, we are done. Bye-bye.